Hello everyone, we are Team Triplify and we will talk about travel management application, the tool that helps to plan individual trips. So let's start with some already existed user with login. We have immediate validations. For example, the field is required, also localized. Then if we enter some invalid password. For example, this one will be invalid. We'll have immediate message, and if everything okay, we will be login. So this is a map of all our objects of our application, of basically places, roads, and we have individual places. It's the core of our application, some place that the person could visit. It has optional cover image, a country, location on the map, and associated items, description. The roads are created from individual places by connecting them in some way. Then we can create the trip itself that has country. For example, we want to travel to, let's say, a few places, but some predefined road that already have some places connected in a strict way. So we can add it and choose the category and a few tags, cover image. Let's choose this one. And everything will be saved. We can easily filter it by countries or by some categories and can see the new planned trip that we want to visit, basically travel. It has a status that can be easily changed, and many categories and roads, places that are configured to this trip. Additionally, we can add images to it when visiting the trip, for example. We want to add some image from some place from this trip for some moment of our life. And it can be easily added and viewed. Additionally, we have some pro functionality, but for that we need a license in some specific format with validation and styling, so it couldn't be compromised. And we can apply the license and see, for example, the calendar of a few trips with some categories that we can visit in specific time periods and also filter by category. We also have a really powerful feature, session. So after basically logging to our application, starting of our application, if user is registered and it not log out, we immediately log in without the manual enter of password or other operations. And with the Pro license, we have some Pro functionality, basically more roads, because with common license, without license, we have only one road per trip. But with the license, we can have multiple. Also, we can specify stories, basically some moments from the trip that have some date, let's say 1330, that have images, obviously, with optional description and location and emotion of our story, like let's say excited, some text. And the story is successfully created and linked here. So we can see it, we can see the parent item and navigate to it. As I said before about the map, it has a clusterization, a really powerful feature that allows us to display basically infinite amount of points because it's clustered in a good way. Also, we can see some individual places that don't have image, so we don't see it, but with some that have, we can see the image also. Yeah, and we can filter clusters. Let's move to the configuration role of our application. Let's create some configuration user. So test user, for example, some username with password and configuration manager role. And with this approach, we could configure our application, basically, for example, ban some countries or change their information, configure categories, emotions, badges, and other information. And let's return to badges because it's the other interesting feature of our application. So let's log in again to our second user. And it has some travel statistic that is loaded from created places, roads, and other data, and badges. And for example, by visiting a country, we can have some badge over time with visiting some amount of country for each level. We have a different amount of badges based on other operations, and it works perfectly. So thank you for your attention and good luck.
Hi, I'm Yuri Olinik and I'm software architect at Triplify team, and I will talk about the architecture, project structure, and diagrams. So I want to start with Archimate diagrams, applications usage viewpoint. So we have three business roles: status user, premium user, and configuration manager. All of them are served with account and license access, which is realized by managed user access business process, and it is served by application service identification and account service, which is realized by application component called Triplify desktop application. The important business service is travel planning, which is served to standard user and premium user. It is implemented by Triplify cycle business process, which contains the safe places, build routes, plan trip, track trip progress, and document travel experience, reviews, statistics, and pages, which those business processes are served with corresponding application services, and which are realized by Triplify desktop applications. And we have premium, then we have enhanced trip experience business service, which is served to premium user and realized by premium features, which includes use calendar view, create travel stores, manage multiply routes, and those are served by corresponding application services. And the configuration manager, the platform administration business service is served to a configuration manager, and platform administration is realized by platform management, which includes business processes such as manage categories, manage amounts, manage budgets, and those are served with platform management service. The next viewpoint is technology. We have three technology services: desktop application execution, local data persistence, and local file storage. They are realized in user computer. Our app is fully client local, including the database we are using SQLite, which is also on the client side. There is operating system which hosts Java runtime environment 25 and provides local file system. The desktop application execution business service is realized by run Triplify application. The Java FX runtime and Java 25 are assigned to it, and it is accessing Triplify application package. For local data persistence is realized by managed local database access. The specialized native extensions, SQLite JDBC driver, and Hikari CP connection pool are assigned to this I misspelled technology process, and they are accessing SQLite database file and specialized native library. And there is last technology service, local file storage, which is realized by technology process manage local file system is assigned to it, and it is accessing the technology artifact stored image files. Then there is layered viewpoint, which includes the business layer, application layer, and the technology layer. Then there is a UML component diagram of our app. So we have 5 main components, which are Gradle modules, the Bootstrap UI application infrastructures and domain. They have the corresponding dependencies. For example, in Bootstrap it's Google Goose and etc. Those blue components, I marked those as blue to emphasize that those are dependencies libraries. So there is Bootstrap, which is using Google Goose and wiring the dependencies and starting the UI. The UI is using the application services. The application module component is using domain. So domain itself don't have any dependencies at all. It defines the core logic and, for example, the repository interfaces, and those interfaces are implemented in infrastructure, which then have dependencies. For example, SQLite JDBC, Specialite, bcrypt, and etc., which is accessing the local storage, which includes SQL database file and the image files. So let's move on to the code. Here's our app. So we have application, Bootstrap, domain, infrastructure, and UI, which are Gradle modules. So about UI, my teammate will talk more in details. So it is using the application interfaces. So the application has the structure, dependency injection, license, security, shared use case, and validation. The important one is, the biggest one is use case, which contains all the services. For example, the map, it contains the map service, interface, the map service implementation, and the DTO, data transfer objects that are used for this. Then we have the domain that is core logic and doesn't have any dependencies. It contains all the app errors, the filters, the map, the model. So this is a database model, pagination, repositories, interfaces that are then implemented in infrastructure. The result, the domain services, interfaces, and some utilities. And in the infrastructure, we have dependency injection, errors, infrastructure error interface, the repository implementations from domain, the security bcrypt, and the local file storage implementation. So a few important classes. The first one is result class, which is in domain. It represents it is used for as return type for application services, for some for repositories and for services. So it is sealed interface which permits result success and result failures. And it contains the methods to work with it, such as awk, fail, is success, is failure, and etc. So this class is generic. It is returning, so it is returned from services and repositories mainly, and it either returns the generic value that it is the generic value, or the failure is, and it is returning the error. And app error is an interface which contains all the errors, which is interface for all the errors in our system, for example, those 55. Then the important one is validating proxy. So we are using Goose for dependency injection and Hibernate validator for the validation of data transfer objects, and we want our data transfer objects to be validated automatically before the event service call. So this validating proxy is wrapping the interface. So it is used. This is how binding works in the Google Goose, and some, for example, services and services implementation via binding. We want to validate our data transfer objects before the function call, to validate all the data and show the error or the error, if any, exists in DTO immediately to the front end, and it is wrapped using the validated proxy. So this is function. It is using Java reflection, and it is basically getting the class itself serves and injects there this function invoke serves, which is called before the service itself. So this is a proxy which is called, and this proxy function just goes through all the arguments, or goes through all the fields so in data transfer object, it tries to validate, and validating it here. So, and this is how it is working, validating through all the fields, and it is how it is used. Such as this is example of data transfer objects, such as not null, not blank, size, minimal, not null, and etc. There is parameters like this, which message to show, and those are automatically validating using this validating proxy and the Google Goose library. And the last one important class is pagination. We are implementing the OSINT-based pagination, and here is a page class which represents one page of paginated result. And there is a page request which represents a request for one page of results. So it contains the page, the size, and it is has the next function, and that's all for me. Thank you.
Hello, my name is Dmitry Brecho, and today I want to present structure of our project. So the front end is located inside the UI model, so we can open UI CRC main Java, Triplify UI, and the several main parts like pages, shared, routing, theme, storage, and map, etc. So it's here. And the pages package contains feature-based screen, so we can open pages, we can see account, pages, calendar, trip, stories, start, setting, routes, places, and etc. And inside this model, we usually have controllers for the main screens, and in some cases, additional model and view package. So we can open trips, and we can see models and also view, and also we can see our controller, and this gives us a clear separation between the list page, the detail page, and the details page. So and also the same pattern is used in route and places, so we can see also model, view, and our controller, and also routes, model, view, and our controllers. So, and the visual part of the front end is stored in resources. So we can open resources, Triplify UI, and also we can open pages. In here we can open trips, and we can see here add trip view fxml, and also my trips view, card, details. Also we can see CSS, and also images, and the same in roads, place, and also we have shared, so we can see here our component, so we can see here button, pages, add card, CSS, and etc. So we can see header, menu, and etc. And so overall, the frontend is organized as a model Java fixed application, future page for business flow, shared reusable component for consistency, routing for navigation, and dedicated packages for styling, localization, and also temporary UI state. So thank you for attention.
Hello, I'm Maxim Anachenko, and now I'll record the overview of the database scheme and database functionality in our app. So at first we will look at the database scheme. Basically, the two main entities are images and users. They have the most references in other tables in our database. So basically we have images with 5 fields: primary key SID, URL, storage key description, and about that. Our ID is of type unique identifier, UUID, but it is stored as text because SQLite does not support UUID type. So basically here we have users. They have image avatar image ID, which is from key for the images. Then we have other main entities such as emotions, categories, countries, routes, places, trips, tags, badges. And stories. Other tables are just junction tables such as user badges, trip images, trip tags, trip countries, trip place images, trip place images, trip route images, and route places, and also trip routes. So that's all for the database scheme. Then we will continue with SpecialLite package. It has 3 packages. There are already built binary files for 3 platforms that is used during the app startup. Then we do have migrations and seeders packages. In migrations, we have main scheme and other version migrations. So here we're creating countries table, another countries table, categories, tree places, expanding color palettes, created pages, and statistics table. Seeders, in Seeders, we do have SQL files that are filling our database with dummy data. Not even dummy, but with data, just with data. Next, I'll go through the implementation. So the most important are database migration initializer and SQLite connection factory. Basically, SQLite connection factory creates a SQLite connection, which is connected to the server path where the database is stored. Basically, our server running on the client PC, so it doesn't matter, it's a server client. So in the main function, the main method of this SQLite connection factory is get connection and get special connection. We're using spatial library for managing geography points and geography data, and also to compute the distance between different points on Earth. Also, we have here a close method which closes SQLite connection. It first closes special connection and then SQLite connection. Here we're also building pool config to reuse resources, and these are rules for the resolving SQLite path for storing database. Also here we have repository implementations which will be taught, I believe, with other members of the team. And also I would show you the storage for images. The storage is implemented using physical storage on the user's PC. So it just stores and deletes photos. Also it validates image type. And that's all for me.
My name is Volodymyr Sorochinsky, and I will show you my part of our work. I will start with license generator. It's a side project which help us to generate licenses. You can see in console I've generated license for 30 days with this name, and I've got a new JSON file in our project. And this is applied in our product. In License Manager, we manage our JSON files and can read, decrypt it, and check if they're alright. Another part of my job here was working with Pages, Pages group, statistics, and user. I was creating all parts for domain and infrastructure. In infrastructure, we have SQL code protected here for creating everything we need. Also some migrations and seeders for all users, and the default one for representation. Also, for each of these parts, I was creating application services, batch services with the following methods, using interfaces for that, and according requests for these parts. And I was mostly responsible also for UI part of our program, where I was implementing our authentication parts, our start page, and all things connected with profile. So updating image, updating username, displaying our profile statistics, badges, and controlling our license.
Hello, my name is Andriy Malkatko, and today I'll be showing you some configuration manager pages and how they work in the code. This is how they look like. And let's go to the code part. First of all, we have some fxml files that describe these pages. Oh, and by the way, I'll be showing you only the countries page because other pages are really very similar to this one, so there would be no point to show you all of them. So it has some grids and V-boxes to describe the main layout. Then we have some inputs defined in here, and you can see that we have containers in here, and actual inputs and buttons will be created in the controller, which I'll show you later. There is also some CSS, of course, to make all of the page more pretty and beautiful. And let's go to the controller, as this is the part where the most logic lives. So as I have mentioned, there are some containers, and to these containers we can assign some inputs and buttons, and this is done in initialize inputs method. Then we have some build buttons, which builds the buttons, obviously, and grid, which is in my opinion one of the most important components, as it's reused in all of the pages, and it's for loading all of the available badges, emotions, categories or countries. There are also some functions for binding text, attaching listeners, and loading countries. Of course, there are some more logic behind all of that, but we don't have a lot of time for me to explain you that, so I will just briefly show you that some services are called. For example, we can just search for service, and we can see that get countries is called from country service, which is in interface, of course, and we have some implementations for that in the application module. You can also see it here. This way frontend can easily communicate with the backend of our program, and that's how we load configuration and also, of course, update and create new countries and other things. Thank you, that's it for me. Have a nice day. Все, типа закончил. Кайф.
Hi, my name is Arseny, and in our project I worked as a UI UX designer. For designing our application, we used Figma as our main tool. It helped us build a clear and consistent structure for the whole interface and make collaboration with the team much easier. To make our design system more efficient and scalable, we used components such as theirs, which allowed us to reuse UI elements across different screens instead of redesigning them every time. All of our frames are fully prototyped. This means we didn't just create static screens, but also connected them into a clickable flow that simulates how the real application will work. So thanks to this, front-end developers can easily go through the prototype, understand the user journey, and get a clear idea of how each page should look and behave. So as you can see, you can click, and I think that's it.
Hello, my name is Vitaly, and today I'll tell you about the design of our app that was designed by me in Figma. So starting with our starting page, then we have sign up and sign in pages. Main page, each page of our app has two designs with sidebar and sidebar minimized. So then we have my trips page with all trips of user, calendar, account with the user profile and all information about him. Then we have add trip, add place and add route pages. They are really similar because they have really similar functionality. Then we have updating and adding story, the same as previous ones. So pages for place, route, story and trip. And pages for trip route and trip place with routes for some trips and places for the trips too.